Project Planning and Control, PPNC. Planning and Baseline Architecture. Course 3 Module 1 Part 1. This will be an introduction to analysis and performance measurement in this first part of Module 1. We'll introduce the PPNC hierarchy and examine how analysts transform raw data into meaningful information, actionable insight, and decision-ready recommendations. Module 1 covers the mindset, the framework, and the practical mechanics of monthly analysis, from where PPNC sits in the hierarchy to burn rate math and the DoD case study. The most important distinction in this module is the one between analysis and assessment. Most analysts never make the jump from describing what happened to interpreting what it means. After this module, students can distinguish analysis from assessment, flag the 4 graph patterns, categorize all 7 variance types, and apply those skills to a real cost-plus program. This module changes the way you look at data. Once you understand constructive value, you can never go back to just making charts. By the end of this module, you'll have the skills needed to move beyond simply reporting program data to providing meaningful analysis, assessment, and decision support. You'll learn how to identify trends, evaluate cost and schedule performance, diagnose the root causes of variances, and assess overall program health. You'll also develop the ability to conduct schedule assessments, interpret earned value management data, and communicate findings in ways that enable leaders to make informed decisions. Together, these capabilities form the foundation of effective program planning and control and position you to become a trusted advisor within your organization. This opening slide establishes the visual identity of the control phase, the continuous monthly cycle that PPNC owns. The image represents the shift from the planning phase covered in Course 2 to the control phase that is the subject of this entire course. Project control is not a one-time activity. It is a rhythm that repeats every month from contract award through project closeout. Your job as a PPNC analyst is to keep that rhythm running, gather, integrate, assess, determine, output, repeat. This diagram shows the full PPNC control loop: gathering information, integrating and analyzing, assessing against the plan, and determining actions and impact. The baseline separates the planning phase from the control phase. Everything in this course operates to the right of that line. TCSR, technical cost, schedule, risk, is the integration thread. PPNC functions only work when all 4 are connected. If your monthly reports address only 1 or 2 of these functions in isolation, you're reporting, not controlling. This diagram shows the planning side of the PPNC cycle, how an executable plan is built from initial planning through output and refinement, all feeding into the control phase. Planning is not a one-time event. The diagram shows plan refinement as a continuous loop. As you learn more about the program, the plan gets updated. That's not a sign of failure. That's the system working correctly. The key output of this entire planning process is a single thing: an executable plan that the control function can measure against. If the plan isn't executable, nothing in the control phase works. When I walk into a program that's struggling in control, the root cause is almost always here: a planning phase that produced a baseline that looked complete but wasn't executable. Get the plan right, and the rest of this course becomes straightforward. This slide breaks the control cycle into its 2 activity tracks: analysis and assessment activities on one side, management activities on the other. The analysis track: integrate data, identify trends, connect cost and schedule/risk, develop forecasts, is the PPNC analyst's primary domain. The management track: adjust plans, replan, revise EAC, monitor actions, is informed by the analysis track. One feeds the other. The output of control is not a report. It is a decision. Everything on this slide exists to support the decision that management needs to make. Operational readiness covers the final transition from Phase D through mission readiness review, flight readiness review, and entry into Phase E. KDPC and KDPD are the two formal gate decisions in this implementation stretch. Each requires PPNC products to support the approval. The Program Commitment Agreement established at KDPC is the benchmark against which all future performance is measured. If the baseline was poorly set at KDPC, every EVM report and variance analysis that follows will be measuring against a fiction. PPNC's cost control activities in phases C and D, tracking performance against the LCC and PCA, updating EACs monthly, conducting variance analysis. The shift from estimating to controlling is a mindset change. You're no longer asking what it will cost. You're asking whether what it is costing is consistent with what was planned. Monthly EAC updates at the control account and WBS level are not administrative tasks. They're the earliest signal that cost growth is forming. Analysts who wait until variances are large and obvious to update the EAC have already failed their project. PPNC scheduling activities in phases C and D, maintaining the IMS, monitoring critical path, performing SRAs, tracking milestones. The IMS is a living document, not a one-time artifact. It must be updated as work evolves and dependencies shift. Near-critical path monitoring is as important as critical path monitoring. A path with 2 weeks of flow today can become critical tomorrow if one task slips. Look-ahead reports and early warning metrics are the outputs that give management time to act before problems become crises. Risk integration in phases C and D. Continuously updating the risk register, conducting risk-informed forecasting, supporting JCL updates. Risk burndown analysis is a specific PPNC product. It asks whether the reserve usage that has occurred has actually retired the risks it was supposed to cover. Congressional reporting triggers JCL updates. The analysis must be defensible to external stakeholders, not just the project team. If your risk register is not being actively updated during phases C and D, you're operating blind during the most expensive phase of the program. EVM implementation in phases C and D. Monthly CPR reporting, CPI/SPI tracking, variance analysis reports, EVMP compliance, DCMA surveillance support. EVM is a contractual requirement for major programs under NPR 7120.5. It is not optional, and DCMA will audit it. The variance analysis report is where the analyst explains what is behind the numbers. It is the narrative that connects the metrics to the project reality. EVM without good variance analysis is just a set of colored gauges. The story behind the numbers is what enables decisions. Integrated planning and reporting in phases C and D. Maintaining the PMB, supporting major reviews, providing analysis books, and early warning system products. The analysis book integrates cost, schedule, risk, and workforce data into a single view. It is the flagship PPNC product for leadership briefings. PPB submissions during execution must stay aligned with updated resource needs. The budget and the work must remain connected throughout implementation. If your PMB does not reflect approved changes, you're measuring performance against a baseline that no longer represents the actual plan. Decision support in phases C and D. Cost and schedule/risk inputs for trade studies, integrated analysis for major reviews, replan, and recovery support. The 3-question framework, what happened, so what, now what, is the delivery standard for all decision support products. Trade studies during design changes and test anomalies are where PPNC adds the most visible value, translating engineering options into cost and schedule impact. If PPNC is not in the room during trade study discussions, the decisions that come out of those rooms will not have integrated cost and schedule inputs. As programs move through phases C and D, PPNC becomes a critical decision support function. At this stage, our role extends beyond tracking performance to helping leadership understand the impact of technical issues, design changes, test anomalies, and emerging risks on cost, schedule, and program objectives. PP&C integrates information from across the program to support major reviews and key decision points, providing leaders with a clear understanding of what happened, why it matters, and what actions to take next. When performance begins to diverge from the plan, these insights help drive effective recovery strategies and keep the program aligned with its objectives. Phase E is operations, tracking mission flight data, managing ongoing costs, and eventually closing out and archiving the project. PP&C activities in Phase E are leaner than Phase D, but they do not stop. Work orders, operation schedules, and cost tracking continue. Closeout and data archiving are often underplanned. The cost and workforce to complete them must be included in the EAC. Phase E lessons learned feed directly into the historical data that makes cost research possible for future programs. Document everything. The PP&C hierarchy is the organizing framework for this entire module. It defines 5 levels of increasing analytical value from data capture at the bottom to communication at the top. The hierarchy is not just a training model. It describes how analysts actually get promoted. People who stay at level 2 do not advance. The monthly rhythm of control activities follows this hierarchy. Gather data, report it, analyze it, assess it, communicate it. Each step builds on the one before. Every activity in this module maps to a level on this hierarchy. By the end, you should be able to place yourself on it and identify your next move up. The 5-level hierarchy diagram: data capture, reporting, analysis, assessment, communicate, and empower, with value increasing at each level. Most organizations have plenty of level 1 and level 2 practitioners. The scarcity, and therefore the value, is at levels 4 and 5. The diagram shows integration at the center. The hierarchy only delivers full value when cost, schedule, risk, and EVM are analyzed together, not in separate reports. If you want to know why your project is struggling with credibility, look at where most of your PP&C effort is concentrated on this pyramid. Integration is required not only within PP&C disciplines, but between PP&C and the engineering team, and between PP&C and program management. The three-way connection, PP&C, engineering, program management, is where the real work happens. Analysts who sit isolated in the business office miss critical context. Integration means that a technical problem identified by engineering immediately becomes a PP&C input. Cost impact, schedule impact, and reserve utilization all update. A PP&C analyst who learns about a major technical issue in the weekly status meeting, rather than before it, is not integrated. Each of the 5 levels is defined. Data gathering collects raw data. Reporting organizes it. Analysis identifies what happened. Assessment interprets what it means. And communicate and empower deliver decision-ready insight. The labels matter. Analysis answers what happened. Assessment answers so what. These are different cognitive tasks requiring different skills. Value increases at each level, and the highest value comes from integration, not from doing each discipline well in isolation. The 5-level hierarchy is both a professional development framework and a diagnostic tool for why a PP&C function is or is not adding value. The shift from data to insight. Data gathering and reporting deliver information. Analysis and assessment transform it into knowledge. Communication translates that into actionable decisions. The phrase data clerk to strategic partner is the career trajectory this course is designed to accelerate. Most organizations value people at the strategic partner level, but staff them with data clerks. The gap is skills, not intent. The hierarchy tells you exactly what skills to develop to move from one level to the next. It is not ambiguous. Analysis and assessment compared side by side. Analysis uses trend charts and variance metrics to describe what happened. Assessment evaluates implications and recommends actions. Analysis without assessment is like reading a blood test without discussing what the results mean for the patient. Together, analysis and assessment shift PPNC from reactive to proactive. The program manager gets insight before the problem becomes a crisis, not after. If your monthly report describes the data but never answers, so what or now what? You're providing analysis without assessment. Communicate and empower is the integrator role at level 5, integrating cost, schedule, risk, and EVM into a coherent story that enables risk-informed trade-offs. This is the highest calling of PPNC. The integrator does not just report. They empower leadership to act with confidence. Decision-ready insights are the product, not summaries, not data dumps, not status updates. Insights that directly enable a specific management decision. If leadership is still confused about project status after your briefing, you have not reached level 5 yet. The storytelling imperative. Numbers alone do not drive decisions. Stories do. Effective PPNC communicates what happened, so what, and now what. This three-part framework, what happened, so what, now what, should govern the structure of every management briefing you ever give. A well-told PPNC story enables leadership to act with confidence because it eliminates ambiguity about what the data means and what needs to happen next. If your briefing answers what happened, but not so what or now what, the program manager has to do the assessment work you should have already done. The consequences of staying at the bottom. Analysts stuck in data-gathering roles generate charts, but not meaning, and provide lagging rather than leading indicators. Projects left to interpret raw data without PPNC context will make decisions based on incomplete information, and the analyst will often be blamed for the outcome. The missed opportunity is significant. Risks not identified early, corrective actions not recommended, leadership confidence in PPNC not built. Analysts who spend all their time on data gathering and reporting are solving a problem the database can solve, not a problem that requires judgment. Hierarchy summary. Value increases as you move up. Analysts evolve from data clerks to strategic partners. Numbers alone do not drive decisions. Stories do. When PPNC rises beyond reporting, it becomes a trusted integrator, and trusted integrators get called first when a project is in trouble. The warning: without integration, projects lose credibility and risk overruns, is not hypothetical. Most major cost overruns involve a PPNC failure at the integration level. The highest performing programs have PPNC analysts operating at level 4 and 5 on this hierarchy. That is not a coincidence. Implementation value consists of the day-to-day tasks that keep the program running: tracking, reporting, tools, charts, work orders, funding activities. Implementation value is necessary and real. The mistake is thinking it is sufficient. Every item on this list is something a tool or a junior analyst can do. The question to ask about every recurring task is, does this inform a decision, or does it just populate a report? Implementation value keeps the lights on. Constructive value is what justifies the PPNC budget. Constructive value is project control analysis and assessment, translating technical and subcontract issues into cost and schedule impact, interpreting trends, explaining what the data means. Raising the bar means shifting time and energy from making charts to interpreting them, from producing data to understanding its implications. The 5 questions on this slide: impact of technical issues, impact of schedule issues, what trends suggest, WBS analysis, what does it all mean, are the 5 questions a good PPNC analyst asks every month. Constructive value is what the Orion program manager was asking for when he said he had no idea what to do with all the data he was receiving. Level 1 is the data foundation. Technical metrics, schedule metrics, financial metrics, risk metrics, and EVM metrics collected at the start of each monthly control cycle. Graphing these metrics immediately provides a trend picture, Trends tell you the direction a project is headed, which is more valuable than any single data point. The list of metrics is not exhaustive. The right metrics are the ones most relevant to what could cause your program to fail. If you cannot collect reliable data at level 1, everything above it on the hierarchy is compromised. Good data collection is not glamorous, but it is foundational. Data collection means familiarizing yourself with the program, not just downloading a report, but understanding the history, constraints, scope, and people behind numbers. Tom Newman's advice is embedded in the speaker notes here. Show an interest in the program. Learn the technical terms. Know the players because they are sources of data. Sources vary significantly by project. Project websites, SharePoint, OMB quarterly reports, GAO quick look products. Major lifecycle review materials are all inputs. The analyst who knows the project deeply will always produce better analysis than the one who only knows how to run the reports. After gathering monthly data, standard reports are generated covering actual costs, budget, workforce, obligations, trends, scheduling, risk, EAC, and EVM. Reporting is a delivery mechanism, not an end in itself. The reports exist to communicate status. They succeed only if the recipient understands the status. The 9 reporting categories listed are not independent. A cost variance and a schedule variance that appear in separate reports may have the same root cause. The analyst who sees across all 9 reporting categories at once is doing level 3 work. The analyst who produces each one separately and hands them to someone else is at level 2. The 5 standard EVM metrics for reporting, CPI, SPI, EAC, VC, TCPI, with their formulas and plain English descriptions. These metrics are the common language of government program performance. If you cannot compute and explain all 5, you are not yet a credible PPNC analyst. VC, budget at completion minus EAC, is one of the most important metrics in this table because it tells you how much money you are likely to need that you do not currently have. Memorize these formulas. They will come up in every program review, every briefing, and every DCMA surveillance visit you will ever attend. The PPNC reporting dashboard concept, a single integrated view with CPI/SPI gauges at the top, cost and schedule curves in the middle, and milestones, risk watch list, and resource trends at the bottom. Dashboards are powerful because they force integration. A green CPI and a red schedule gauge in the same view immediately raises a question that neither metric raises alone. The benefit of a dashboard is rapid decision-making. A program manager should be able to assess overall project health in under 2 minutes. If your program manager spends 45 minutes reading individual reports before they understand status, the reporting system is a level 2 system. A dashboard is the beginning of level 3. Why reporting matters. It provides objective performance status, enables early warning, supports decision-making, and creates a common language between technical and business teams. The phrase creates a common language is important. Engineers and project managers think in technical terms. Reporting translates those into business terms that executives can act on. Reporting feeds the next levels of the hierarchy. Without reliable reports, analysis has nothing to analyze. The quality of your level 2 reporting determines the quality of everything above it. Bad data in, bad assessment out. Level 3 analysis builds an integrated characterization of the project, ground rules and assumptions, cost and schedule drivers, risks, and a summary of project logic and cost by element. There is never a shortage of data to analyze. The discipline is in selecting what to analyze. Pareto applies here as much as anywhere else. Building a cost/resource loaded schedule is a level 3 activity. It requires connecting the schedule to cost in a way that reveals what is actually driving both. By the time you finish level 3 analysis, you should be able to answer the question, what are the 3 things most likely to cause this program to miss its cost or schedule objectives? Level 3 analysis continued, developing schedule performance analysis, translating risks into potential cost and schedule impacts, building fixed versus variable cost characterizations. Translating risks into cost impacts is where QRA concepts begin. This is not a separate activity from analysis. It is part of the same integrated picture. Fixed versus variable cost characterization matters because schedule slips only drive cost growth into variable cost elements. Fixed costs are sunk regardless of timing. An analyst who can build an integrated cost and schedule characterization of a program has delivered something that no report generator can replicate. Basic project information to know at Level 3. Level 1 requirements, where they are found, how they drive mission, program highlights, life cycle costs, key risk areas, and reasonable expectations. Know where to obtain data from past NASA and DoD missions. Historical precedent is the most powerful tool an analyst has for calibrating whether current estimates are credible. Reasonable expectations are the hardest element on this list to develop. It takes years of experience and deliberate study of historical programs to build. An analyst who does not know the historical cost and schedule performance of similar programs cannot tell whether the current plan is credible or wishful thinking. Recent trends to track: 3-month and 6-month TPM, cost, schedule, workforce, and UFE utilization, critical path and schedule drivers, EVM indicators, risk capture, similar mission comparison, acquisition issues. 3-month and 6-month trend windows are the most useful. They smooth out monthly noise while still catching emerging problems early enough to act on them. Acquisition issues from the acquisition strategy plan and project plan are often the earliest indicators of schedule risk that will not show up in the schedule for months. If your monthly analysis only covers the current month, you are looking at a snapshot. Trends require at least 3 data points to be meaningful. Level 4 assembles the analysis into a storyboard, honing in on the information that conveys a concise story, asking key questions, building a narrative, including options and recommendations. The storyboard is a physical or virtual organizing tool. It forces the analyst to decide what is important before they start building the briefing. What-if scenarios are a Level 4 product that most analysts skip. They require the analyst to model the sensitivity of the project to key assumptions, which is difficult but extremely valuable. If the information is not going to be well received, have the data ready to defend the position. Assessment requires both judgment and courage. Analysis is defined as the resolution or separation of data into its component parts to illuminate their nature, interrelations, and general principles of behavior. The definition is important because it implies work. Analysis is an active process of decomposition and examination, not a passive process of receiving reports. The goal is to understand the nature of the data and how the parts relate to each other, not just to read the total numbers, but to understand what is driving them. If your analysis does not involve separating something into its parts to understand it better, you are summarizing, not analyzing. Analysis versus assessment. Analysis asks what the facts and relationships between them are and explains. Assessment asks what the implications are and interprets. The blood test analogy is the clearest way to explain this distinction. Analysis is getting the lab readout. Assessment is what it means for your health and what you need to do about it. Analysis is not running a BOBJ report, entering data into a spreadsheet, or executing a computer-generated output. Analysis is the human judgment applied to what the numbers reveal. Projects that confuse analysis with reporting end up with analysts who are excellent at producing charts and terrible at explaining what those charts mean. Why separate data into parts? Because aggregate data conceals information. Looking at a program-level total can show everything is fine when major problems are buried in lower-level WBS elements. The classic failure mode is a program that looks healthy at the top-level WBS, but has severe cost growth concentrated in one subsystem that is being masked by underruns elsewhere. Disaggregation is not the goal. it is the method. The goal is to find what is actually driving performance, which is almost never visible at the aggregate level. Never stop at the top level. Always ask what is inside the number before accepting that everything is on track. There are many aspects of a project to analyze. All technical and schedule aspects impact cost and ultimately budget. Key drivers are different for each project. Fundamental understanding of how technical, cost, and schedule interact is vital. You cannot analyze cost in isolation because cost is downstream of every technical decision. Many tools and techniques exist to perform integrated assessments. Tools enable forecasting of future performance based on past performance, which is their primary value. The analyst who understands the technical system being built will always produce better analysis than the one who only understands the financial system being reported on. Good analysts compare plan to expectations and flag areas that do not meet expectations. Common sense correlation means building an intuition for what things should cost. The KSC/VAB example from the speaker notes is instructive. If someone said a new VB would cost $150 million, it sounds plausible until you know the real answer is $3 billion. You need a reference point. Over time, the most valuable asset you build is a broad knowledge base applicable to as many facets of your program as possible. An analyst without a basis for comparison cannot challenge an estimate. Building that basis is a career-long investment that starts today. The most important element in analysis is determining a reasonable expectation to compare against, built from understanding what the program needs to succeed, what technical problems exist, the political environment, and the capabilities of the people doing the work. The capabilities of people doing the work are the most overlooked factor in cost estimation. A team doing something for the first time will cost more and take longer than a team that has done it before. A broad knowledge base means knowing the program, the technology, the history of similar programs, and the political pressures on the project. Reasonable expectations are not invented. They are built through study, experience, and deliberate accumulation of historical knowledge. Areas that do not meet expectations are flagged and investigated in detail, asking project personnel to explain unusual patterns, using best available data when deep dives are not feasible. Deep diving every line item is the ideal, but it is rarely achievable on complex programs with aggressive schedules. Pareto prioritization is how you focus your limited time. When you cannot fully investigate something, caveat the strength of your expectations in the report to management. Transparency about uncertainty is a credibility builder. Flagging something as unusual and asking for an explanation is itself a form of quality control. It signals to the project team that their numbers are being examined. Bias in data sources, contractors. The government-contractor relationship discourages accurate strategic cost and schedule information because of competitive bidding and changing requirements. Contractors have no incentive to surface bad news early. If they tell you the schedule is slipping, they risk renegotiation, fee reduction, and scrutiny. So they do not tell you until they have to. Managers must not shoot the messenger. If bad news is punished, people stop bringing it, and failure is then guaranteed. Your job as the analyst is to find the bad news the contractor is not volunteering. That requires asking different questions, digging into lower WBS levels, and comparing actuals to what similar programs experienced at the same point. Bias in data sources, project managers. PMs are paid to be can-do people. They negotiate contractors down, they take an advocacy role, and they always see a workaround. "There's always a workaround" is the most dangerous phrase in program management. It usually means the problem is being deferred, not solved, and the cost will show up later with interest. Project managers get caught up in today's problems and 60-hour work weeks. They're genuinely not trying to deceive. They're optimistic by personality and role. The analyst's job is to maintain objectivity when the project manager's optimism is under pressure. Someone has to hold the line on realism. Reliability factors. Personal contact is more valuable than email, and over time you assign reliability factors to your sources. Management assigns them to you. A source's reliability factor is not permanent. It changes based on how often their forecasts prove accurate. Track your sources the same way you would track a contractor's cost performance. Establishing a good reliability factor for yourself means being consistently accurate, not consistently optimistic. Accuracy is what management needs. The analyst who is never wrong is usually the one who never says anything definitive. The analyst who is reliably accurate, even when the news is bad, is the one who gets called before major reviews. The easiest way to analyze numbers is through graphs. NASA programs produce massive amounts of data, and visual trends are impossible to miss, whereas tables of numbers are easy to overlook. The WI data table on this slide has a typo in Widget 2. February shows $1.52 instead of $15.20. In the table, it is easy to miss. In a graph, it is impossible to ignore. Two important observations from the table: the Widget 2 anomaly and the fact that Widgets 1, 3, and 4 are all trending downward in the last quarter, while Widget 2 is trending up. Both are visible in the graph and hidden in the table. Graph your data before you analyze it. You will see things in the graph that you will miss in the numbers every single time. The value of graphs is demonstrated. The Widget 2 typo is impossible to miss when graphed, and the diverging trend between Widget 2 and the others is immediately visible. The difference in trends should be investigated not because it is definitively wrong, but because there is not enough information to determine why, and that is exactly the kind of anomaly worth asking about. Graphing also reveals pattern anomalies, peaks, dips, and divergences that would take much longer to detect by reading numbers. The graph does not give you the answer. It tells you where to look for the answer. That is the entire value proposition of visualization in PP&C. Before graphing, convert budgets to constant year dollars to remove inflation effects that can mask real inflections in the data. The NASA New Start Inflation Index shows how significantly inflation can vary year to year. If you do not account for it, a curve that looks flat in real year dollars may actually be declining in constant year terms. Noticing inflections is easier in constant year format. The underlying trajectory of cost growth or decline is visible without the noise of annual inflation rate variation. Always convert to constant dollars before graphing multi-year cost data. Failure to do this is a common source of misleading cost trend analysis. What to look for when graphing? 4 specific patterns that warrant further investigation: steep buildups, severe drop-offs, dips, and short peak periods. These are not automatic red flags. They're signals that something needs to be explained. The explanation may be perfectly reasonable. The problem is when there is no explanation. Monthly and quarterly format can reveal trends masked when data is rolled up annually. Always look at the most granular time resolution available. These 4 patterns are the basis for the next several slides. Each one has specific questions that the analyst should ask when it appears in the data. Steep buildups could indicate a constrained schedule requiring an aggressive plan. Going from 0 to 66% of peak staffing in 1 year is possible in some circumstances, but requires investigation. The question is not whether a steep buildup is wrong. It is whether there is a credible explanation for how the workforce ramp rate is achievable. For DDT&E, historically about 15 to 20% of funds are spent by PDR. If the buildup deviates significantly from that, investigation is warranted. A steep buildup that cannot be explained by a specific program event, a contract start, a phase transition, or a major procurement is likely a success-oriented plan that will not be achieved. This slide recaps the Level 3 analysis objective within the flow of the Analysis Basics section, a reminder that all the techniques being discussed are in service of the Level 3 goal. The analysis tools covered in this module, graphing, pattern recognition, bias awareness, burn rate math, are the specific mechanics that make Level 3 analysis possible. Building an integrated cost and schedule characterization of the project is the Level 3 deliverable. These slides are teaching you how to build it. Every time you apply one of these techniques, you are adding to the integrated picture that makes Level 4 assessment possible. Repeat of the analysis definition, resolution, and separation of data into parts to illuminate their nature and interrelations. The repetition of this definition is intentional. It anchors the practical techniques that follow back to the core principle. Each of the 4 graph patterns covered in this section is an application of separation, taking a single aggregate number and breaking it into its temporal or functional components to reveal what is hidden inside. Separation is the operative word. The analyst who learns to separate data habitually will find problems that aggregate analysis will always miss. One of the most common problems in development programs is assuming the workforce can ramp up faster than reality allows. Historical NASA data shows that organizations often underestimate the time required to recruit, train, and integrate skilled personnel, leading to overly optimistic cost and schedule plans. As analysts, we use established benchmarks, such as spending approximately 15 to 20% of DD&E funds by preliminary design review and limiting operations workforce growth to about 30% per year, as starting points for evaluating plan credibility. These are not hard rules, but when a program deviates significantly from them, it should prompt questions. A steep workforce or cost buildup should be supported by a corresponding program event or milestone. If it isn't, the plan may be unrealistic. The goal is not to assume the estimate is wrong, but to understand what makes this program different and whether the assumptions are truly achievable. Additional watch items for steep buildups. The same DD&E and operations benchmarks presented for emphasis, with the same investigation trigger if the ramp rate is exceeded. The repetition of these benchmarks in multiple slides reflects how often analysts encounter aggressive ramp assumptions in real programs. This is not a theoretical problem. The milestone overlay technique is simple but powerful. It requires the analyst to connect the financial plan to the technical plan, which is exactly the integration work that adds constructive value. A plan that cannot be connected to specific program milestones is a financial plan, not a project plan. That distinction matters for assessment credibility. Severe drop-offs could indicate a front-loaded plan attempting to meet a cost mark. FI5 at peak spending dropping 75% in 1 year warrants investigation. PMs are often given constrained budgets and forced to make aggressive assumptions. Limiting workforce overlap at the DD&E to operations transition is a common tactic. It is also one that is rarely realized. Steep drops at the end of DD&E are almost never achieved in practice because test anomalies, rework, and integration challenges almost always extend the development workforce longer than planned. When you see a severe drop-off, ask how the program plans to execute the transition. The answer will usually reveal either a credible plan or wishful thinking. Contractors prefer to front-load their plans. It gives them flexibility and minimizes the chance of overages that could impact the award fee. Contractors also know from experience that scope changes from the government will come, and those changes will let them get well if they have built in a front-loaded buffer. This front-loading motivation is not deceptive in intent. It is a rational response to the incentive structure. But it means the plan is not a true reflection of when work will be performed. A front-loaded contractor plan is a negotiating position, not an execution forecast. Treat it accordingly. Dips. Temporary dips occur most often in the operations phase. Planned dips during development are often artificial, imposed by budget constraints rather than by the actual work plan. ODC dips are much more realistic than workforce dips because you can stop buying equipment while keeping people. Planned workforce reductions require someone to actually terminate or move employees. The key question when a dip appears is this: ODC or headcount? If headcount, where are those people going and how do you plan to bring them back when needed? Aggressive assumptions about second shift efficiency are a common way of making the math work during a dip period. Studies consistently show additional shifts are less efficient per hour than planned. Short peak periods, often caused by success-oriented development plans. Peak spending usually occurs near CDR, which is where most risk resides. Underestimating this phase causes significant overruns. A peak year that is 33% higher than adjacent years, combined with a level workforce, implies that the program plans to fire people immediately after reaching peak. That almost never happens. CDR is the high-risk moment in the life cycle. It is where design problems are discovered, rework is triggered, and integration challenges first appear. Peak costs here should be credibly sized, not minimized. Ask what is causing the peak. Workforce overlap during transition is realistic. A single year of peak labor because designers are released is not. What to watch for in short peak periods: embedded contingency for rework, unknown unknowns during qualification, workforce overlap at phase transitions, and maintaining sufficient UFE in following years if the peak extends. Problems are often identified during qualification that were not anticipated. This is the nature of the qualification phase. A peak plan that does not include a rework contingency is success-oriented. If the peak looks realistic, the follow-on question is whether there is enough UFE in the years after the peak to cover an extension, because extending the peak is almost always what actually happens. The peak period is where programs most commonly underestimate cost. If the plan is tight here, reserves need to be sized accordingly. Burn rate math. Plan for the year is 20 WY. Actual in Q1 is 10 WY. What does the program need to average for the remaining 3 quarters to meet the annual plan? This is one of the most practically useful calculations an analyst can make during the monthly cycle. It translates a variance into a forward-looking workforce requirement. The setup question is straightforward. What average rate is needed over the remaining quarters? The answer on the next slide reveals a critical insight. Before answering this question, most analysts instinctively compare to the previous plan. The next slide shows why that instinct leads to the wrong conclusion. The answer: to meet 20 WY for the year after 10 WY in Q1, the program needs to average 23.3 WY per quarter, which requires more than doubling the workforce almost instantly. While 23.3 versus 20 looks like only 17% over plan, the real issue is the ramp required. Going from 10 to 23 in 1 quarter is a near doubling that is very unlikely to be achievable. Do not get lost comparing to the previous plan. If the previous plan was accurate, the higher burn rate would not be necessary. The previous plan's credibility is already in question. This calculation should be performed every month on any WBS element that is running behind. The required future ramp rate is the most important number to present to a program manager. What's up next? Module 1: Analysis and Assessment Fundamentals. Module 1 Part 2 up next.